Hi, third grade. Are you ready to learn? I hope you are. Okay, we're going to start a new unit on fractions. So let's review fractions. There is an introduction to fractions video by Antics on YouTube titled Fractions Are Parts. I will also upload a link or copy a link for you on Moodle. In addition, I will show you the link in my description on my YouTube channel. Okay?
If you've been learning math for a while, then you probably already know a thing or two about fractions. And if you've ever had to, break a cookie in half to share with a friend, well, then you've used fractions in real life. Oh, well, thank you. Mm. That's because fractions are used to represent smaller pieces or parts of things. When you're first learning about fractions, it can help to draw pictures to see how they work. So let's start by drawing a circle. Now, this circle represents what we call a hole. Now, not the kind of hole you can fall into, more like a whole cookie or a whole pizza. Now, if we divide that circle or whole amount into 4 parts, then we call each of those parts a fraction of the original whole circle. Because this is math and not art, we can't just keep on drawing pictures. We need to learn how to write out fractions using the language of math. Yep, you guessed it. That means using numbers. Unlike a regular number, to write a fraction you need 2 numbers. One number on top, one number on bottom, and a line between them. I'll explain exactly what the line's for later in the video. But for now, let's figure out what those 2 numbers mean. Remember, fractions are used to represent parts of something. And the number on the bottom tells us how many parts that something is divided into. The number on top tells us how many of those parts we have. For example, let's write a fraction for our drawing here. I divided the circle into 4 parts, right? So the number on the bottom will be 4. And I still have all 4 of those parts, so the number on top will also be 4. I have 4 out of 4 parts. That means I still have a whole circle. But what if somebody came by and took away 1 part from the circle? Well, the circle's still divided into 4 parts, so the bottom number would still be 4. But I only have 3 of those parts left. So that means the top number will change to 3. So I have 3 over 4, or 3/4 of a circle. Make sense so far? Good. Let's try another example. Let's say that I divide a rectangle up into 8 parts, and I give you 3 of those parts. Since the total number of parts is 8, the bottom number will be 8. And since you have 3 of those parts, the top number will be 3. So the fraction I'm giving you is 3 over 8, or 3/8 of the rectangle. No need of that. Oh, and it's important to remember that for fractions to work right, the parts that you divide the whole up into have to be equal. We can't take a candy bar and say, well, I'm going to divide it into 2 parts, so this is your half, and here's my half. Let's look at a few more examples so you can really see the pattern of how fractions can represent parts of objects. This rectangle is divided up into 3 equal parts, and 2 of them are shaded red. So 2 over 3, or 2/3 of the rectangle, is shaded red. The circle is divided into 12 equal parts, and 7 of those parts are shaded green. So 7 over 12, or 7/12 of the circle, is shaded green. The hexagon is divided into 6 equal parts, and 5 of those parts are shaded blue. So 5 over 6, or 5/6 of the hexagon, is shaded blue. All right, so you can see how fractions can be used to represent parts of objects like circles and rectangles, but fractions can be used for more than that. They can be used to represent parts of, anything, like pets, for example. Let's say you have 7 pets, 4 dogs, 2 cats, and a big fat hamster. Well, that means that 4 over 7, or 4/7 of your pets are dogs, and 2 over 7, or 2/7 of your pets are cats, and 1 over 7, or 1/7 of your pets are hamsters. It also means that your house probably smells like a pet store. Okay, so fractions can be used to represent anything from parts of a circle to kitty cats. But did you know that fractions can also be used to represent things you can't even see? Well, like a test score, for example. Let's say you take a math test and there's 20 questions on the test, and you get 17 of those questions right. That means that you got 17 over 20, or 17/20ths of the questions right. All right, so that's the basic idea of how fractions can be used to represent parts of things. But there's a lot more to fractions than that. In the next section, we're going to be looking at some of the other things we can do with fractions. But before that, let's review. Fractions are used to represent parts of a whole. Fractions are written in the form of a top number over a bottom number with a line between them. The bottom number represents how many parts the whole is divided into, and the top number represents how many of those parts you have. And finally, the parts that a whole is divided up into must be equal for fractions to work right. To really understand how fractions are used to represent parts of things, be sure to do the exercises. And I'll see you in section 2. Learn.
Okay, so let's just continue with fractions. All right, so look at this example here. We have a cake, and this cake was divided into 5 equal parts. You see that? Kind of looks like the chocolate, a Kit Kat bar. But in this example, it's a cake that's divided into 5 equal parts. And look at that, I outlined this in green to represent the whole. That's the entire cake. This one slice here is called a part. There are 1, 2, 3, 4, 5 total parts in this whole. Let's look at another example. This green outline represents the what? The whole or the part? The whole. What about this shaded pink piece here? What does that represent? The whole or the part? Well, that represents the part. When we write a fraction, we're going to write the number of parts it's talking about, and we're going to draw a fraction bar, and then underneath it we're going to write the total parts of the whole. Okay? So, in other words, we draw a fraction bar. On top, we write the specified parts. The specified parts might be the color that it asks you to. How many, what's the fraction of the pieces that are pink? Then it would be 1 out of, and then the total parts are 1, 2, 3, 4, 5. Or it might say, what is the fraction of the pieces that are unshaded? Then the unshaded part would be the specified part, right? So it would be 1, 2, 3, 4, 4 out of 5. Okay. So in this case, let's talk about what is the fraction of the shaded pieces. So on the top, I write 1 because that's the shaded part, and then on the bottom of the fraction part, on the bottom of the fraction bar, I write a 5 because that's the total parts, 1, 2, 3, 4, 5 in the whole. And how do we say this? Okay, well, you can say it as like 1 over 5 or 1 out of 5, or you can also read this as 1/5, where 1 talks about the top number above the fraction bar, and where this number here at the bottom, we say it as 5th, not 5. In fact, whenever we read a fraction, let's look at this fraction, 1 out of 6. We read it as, so look at the top number, it's 1, and then the bottom number, do we say 6 or 6th? 6 or 6th? We say it as 6th, okay? Let's look at this last one, okay? 1 out of 12, but we say it as, we read it as 1/12, not 1/12. Okay, and so here, this would be 1/7, this would be 1/8, this would be 1/9, this would be 1/10, this would be 1/11, like so. Now, look at these fractions in this blue box, okay? These fractions are also called unit fractions. The reason why these fractions are called unit fractions is, what do they have all in common? Well, the top number is all the same. It's all 1. Whenever the top number of a fraction is 1, it's called a unit fraction. All right, now it's your turn. Please pause the video and try this on your own. See you soon. Hey, welcome back. All right, let's do this together. It says the whole is divided into, so the whole is this entire polygon, which is a hexagon because there are 6 sides. And how many equal parts does this hexagon have, this whole? 1, 2, 3, 4, 5, 6. So there are 6 equal parts. Now, of the whole is shaded. And they're talking about a fraction because I see a fraction bar here. So the shaded is a specified part, and I put it at the top. The total number of parts is 6, which we figured out from here. So it is 1/6 of the whole is shaded. And now here, how do I write that in words? I write it as 1/6 of the whole is shaded. How'd you do? All right, now let's talk about non-unit fractions. When we're talking about non-unit, this means fractions where the top number is not a 1. It could be a 2, a 3, a 5, a 10, 100, and so on. Okay, a non-unit fraction is a fraction where the top number is not a 1. So let's look at this example. Now the red here has 2 parts. What about the yellow? How many parts does the yellow have? Oh, I count 1, 2, 3 parts. What about the total? How many parts are in the total? The total has 5 parts. What fraction of the whole is red? So now I know I have to write it in a fraction. So that means I have to draw a fraction bar, and I need a top number and I need a bottom number. My top number is a specified part. The specified part in this case is the color red. How many parts are red? That's 2. And then my bottom number is the total number. How many parts do I have in the total? There's 5. So it's red over total, which is 2 out of 5. And we read this as 2/5, where the 2 refers to the top number and 5ths refers to the bottom number. Now notice here, I put an S at the end of 5th. Why did I put an S here? Because the number 2 is more than 1. So I'm showing that it's plural. There's more than 1 by adding an S. With the unit fraction, I'll just show you in the previous video or the previous slide. Okay? In the unit fraction, we didn't put an S to describe the bottom number. Okay? Let me just show you here. Okay? Look at this, right? 1/6, no S. 1/7, no S. 1/8, no S. 1/9, no S. 1/10, no S. 1/11, no S. 1/12, no S. Because this is only describing how many? 1. So it's singular, so no S, okay, to show that it's plural. Okay? All right. Let me just click through this. All right. Okay, So it's your turn. Please pause the video and try numbers 2 through 10 on your own. When you're ready, hit the play button. I'll be waiting. All right, you must be ready. Let's do number 2 together. The whole is made up of how many equal parts? Well, I see in this circle there are 1, 2, 3, 4, 5, 6 equal parts. And how many parts are shaded? Okay, and it's a fraction, right? So 1, 2, 3, 4, 4/6 of the circle is shaded. Let's look at 3. We have to write this in words. The top number, we just say the number, and then the bottom number, we have to say it like with the th, right? So 4/6. Okay. What about this? 5/12. What about number 5? 1/9. What about number 6 here? 4/10. Okay. All right. Let's look at numbers 7, 8, 9, and 10. So this rectangle is divided into how many equal parts? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 equal parts. And how many parts are shaded? 1, 2, 3, 4, 5, 6. Okay. So 10 equal parts and 6 parts are shaded. What fraction of the rectangle is shaded? So they want a fraction, so I'm going to draw a fraction bar. So I know the top number is the shaded number and the bottom number is the total. The shaded parts are 6 and then the total parts are 10. So it's 6/10. What fraction of the rectangle is not shaded? So again, they're asking for a fraction, so I'm going to draw a fraction bar. So not shaded is the specified parts, and that's 1, 2, 3, 4 parts that are not shaded. And the bottom number is the total parts, which is 10. Those 4/10. Okay. And here, if we have the shaded plus the unshaded, it makes one whole. So what's the fraction of the shaded? And what's the fraction of the unshaded? Together, they make one whole. So 6/10 and 4/10 together make one whole. How'd you do? I think you guys are getting the hang of it. All right. Now, let's talk about these words, numerator and denominator, okay? So look at this example. How many parts are shaded? How many parts are unshaded? How many parts are in the total? Well, for the shaded, I see that there's 1, 2 parts. For the unshaded, there's only 1 part here. And for the total, there are 1, 2, 3 parts. What fraction of the circle is shaded? So you want a fraction, so I'm going to draw a fraction bar, and I know I need a top number and a bottom number. My top number, the specified part is shaded. So how many parts are shaded? It looks like 2 parts. And what's my total part? 3. So it's 2 out of 3, and we say it 2/3. Now, instead of saying the top number, we can now use a math vocabulary word. We call the top number in a fraction a numerator, and we call the bottom number a denominator. Okay, so going forward, I'm going to try to utilize the words numerator and denominator when describing fractions. All right, now it's your turn. Okay, try to do numbers 11, 12, and 13 on your own. Okay, I'll see you when you're ready. All right, hey again. Let's try 11. Of the circle is shaded. So this is talking about a fraction, okay? So what fraction of the circle is shaded? So you know you need a fraction bar, okay? And the numerator is the top number, so it's 1, 2, 3, 4, 5, 6. And the total number, total parts is 10. I'm sorry, total parts is 8, because there's 1, 2, 3, 4, 5, 6, 7, 8. And 8 goes in the denominator, okay? Number 12, the numerator of the fraction is, numerator, does it refer to the top number or the bottom number? The top number, so it's a 6. And the denominator of the fraction refers to the bottom number, and that's a 8. All right, way to go. We'll keep practicing. and I will see you tomorrow during our live class.